Doing fine. Now in this part I am going to tell you about the reasons and several types of discontinuities. Now there are two main types of discontinuities, one of which is removable type and the second one is non-removable type. Now we are going to talk about both these types in brief in this part. So let's watch this. Okay, so now let's discuss about reasons and types of discontinuity. Okay, so in this, first of all, let me tell you what are the reasons of discontinuity, right? Why the function becomes discontinuous? What are the reasons for that, right? So first of all, to understand this, first of all you tell me when a function is continuous, right? A function will be continuous if LHL is equal to RHL is equal to the value of the function is equal to finite, right? If LHL equal to RHL equal to f of a is equal to finite, then the function will be continuous, otherwise it will be discontinuous, right? So if this condition fails to occur, then we will say that the function will be discontinuous, right? If this condition fails to satisfy basically, right, then the function will be discontinuous. Okay, so the first reason for the function to be discontinuous will be the limit itself does not exist, right? If limit does not exist, then the function will be obviously discontinuous, right? Because limit should exist, function should be defined, and both of them should be equal and both of them should be finite. Then only the function will be continuous, otherwise it will be discontinuous. Okay, so first reason can be limit does not exist. Okay, and a good example for this could be if the graph is like this. We saw this graph, right? If the graph is like this, in this case limit does not exist. Right, function is defined, f of a is well defined, this is defined, but limit does not exist. What is limit? Does not exist. Okay, DNE does not exist. Okay, so this is the first reason. Second reason is function is not defined. Okay, limit exists but function is not defined. Example could be like this. Suppose the graph is like this. In this case limit is defined, limit exists. Limit exists, limit of the function exists, but the function is not defined at this particular point a. F of a is not defined. Okay, so limit exists but function is not defined. First case is function is defined but limit does not exist. Okay, and the third case is both are defined. Limit also exists and function is also defined, but both of them are not equal, right? They should be equal also. Okay, so there are only two conditions or three conditions rather which we will have to check. First of all, find out the limit. Limit should exist, function should be defined, and both of them should be equal and finite. Okay, so these are the three conditions for a function to be continuous. If any one of the condition is violated, then the function will be discontinuous, simply. Okay, let us go to the next slide and check whether this function, okay, a graph of a particular function fx is given to you. This is the graph of a particular function fx. You have to tell me, okay, at which points this function is discontinuous first of all, okay, and what are the reasons for this discontinuity. Okay, so first of all let me check, okay, one by one, starting with x equal to 0. Now first of all tell me at x equal to 0 whether this function is continuous or not, right? So what is the value of f of 0? If I want to check at x equal to 0, f of 0 is 1, right? And 0 minus is not defined. F of 0 minus is not defined because there is no graph to the left side of 0, but there is some graph to the right side of 0, right? So left side is completely not defined. Okay, so in this case we will say that the function is right continuous. We learned about right continuous and left continuous, right? Here left side is not defined, so we will only talk about the right side. Okay, so in this case f of 0 is equal to 1 and f of 0 plus, what will be the limit at f of 0 plus? The value of the function at f of 0 plus will be how much? This will be also 1, right? So limit is equal to 1, value of the function is equal to 1, and 1 is a finite number. Okay, so at x equal to 0 function is continuous because limit is equal to the value of the function is equal to finite and it is equal. Okay, now let me talk about the continuity or the discontinuity at x equal to 1. Now at x equal to 1 you can clearly see that we will have to lift the pen, right? If I am passing through this point x equal to 1, right, first the graph was going like this and now it suddenly there is a jump of this amount, there is a jump of 1, right? So this is a discontinuous function at x equal to 1, it is discontinuous. But now here you will have to tell me what is the reason for discontinuity, right? What is f of 1? F of 1 is well defined, right? What is f of 1? See here there is a dot, so f of 1 is 1, right? Here there is a circle, so f of 1 is not 0, f of 1 is 1, right? So f of 1 is 1, which is very well defined, f of 1 is 1, which is defined, but in this case limit is not exist, limit does not exist. So reason for discontinuity is function is defined but limit does not exist, right? Now check at x equal to 2. At x equal to 2, if I check, again I see that here there is a circle. If there is a circle here, I will have to lift the pen, right? And what is f of 2? So again it will be discontinuous function because I will have to lift the pen, so it is obviously discontinuous. But what is the reason for discontinuity? What is f of 2? F of 2 is not defined because there is a circle here and there is dot nowhere, right? So f of 2 is not defined. So in this case the function is not defined. That is why this fx is discontinuous at x equal to 2, because f of 2 is not defined, right? So again at x equal to 2 it is discontinuous. At x equal to 3, at x equal to 3 you can see that again you will have to lift the pen, right? Because here there is a circle and here there is a dot. Okay, so what is f of 3? F of 3 is nothing but 3, right? Here there is a dot, so f of 3 is 3. And what is the limit? What will be the limit? Limit will be for 3 plus and 3 minus, check the value of the function. For 3 plus it will be somewhere around 2, and for 3 minus also it will be somewhere around 2. Okay, so limit of this function at x equal to 3 will be nothing but 2. So limit at x tending to 3 of fx, this is equal to 2. So limit also exists, function is also defined, right? Function is also defined, limit also exists, but both of them are not equal. Value of the function is 3, limit is 2, so both of them are not equal. So this is again discontinuous at x equal to 3. Now check at x equal to 4. At x equal to 4 you can clearly see that here there is a dot, it is not a circle, right? So you will not have to lift the pen, you can directly go from here and here. Okay, so no need to lift the pen. So function is continuous, and if the function is continuous, you can see from the graph also that LHL is equal to RHL is equal to the value of function at x equal to 4, and which is equal to how much? 1. The value of the function is x equal to 1 here, right? At x equal to 4 we will get y equal to 1, right? Now check at x equal to 5. At x equal to 5 we can see that this graph is going up to infinity, and at x equal to 5 plus, this is x equal to 5, this point. So at x equal to 5 minus, this graph is going up to infinite, and at x equal to 5 plus, this is 5 minus and this is 5 plus. At 5 plus it is going up to minus infinity. Okay, so here what is LHL? LHL is 5 minus, f of 5 minus, and f of 5 minus is going up to infinity. And what is RHL? RHL is f of 5 plus, and f of 5 plus is going up to minus infinity. So in this case you can see that limit is not, okay, LHL and RHL are not finite at all, right? And I told you that LHL equal to RHL equal to value of function should be finite. Here LHL is not finite, RHL is not finite, both are going up to infinity. So this means that limit does not exist. Also value of the function is not defined. F of 5 is not defined because it cannot be infinity. So function is also not defined, limit is also not defined, and both are not finite also. So function will be discontinuous. So you understood, right, how to check at different points and what can be the reasons or what may be the reasons for discontinuity, right? If any one of the three conditions are violated, then the function will be discontinuous. Or if LHL is equal to RHL is equal to the value of the function is equal to finite, then the function will be continuous. Okay, it should be crystal clear. Okay, now let us discuss about all the types of discontinuity in one slide itself. Okay, so that there is no confusion in future, right? So what are the types of discontinuities, right? Now there are two main types of discontinuities. One is removable and the another is non-removable. Removable types of discontinuity are those discontinuities which can be removed by changing slightly in the definition of the function. Okay, so this type of discontinuities, removable discontinuities, can be removed by changing the definition of the function slightly, right? So defining the function something else, right? So slight change in the definition of the function, we can remove this type of discontinuities, we can make it continuous. And non-removable are whatever we do, we cannot remove the discontinuity, right? We cannot make that function continuous anyhow. Such types of discontinuities are called non-removable discontinuities, right? So types of discontinuities, there are two major types. One is removable and one is non-removable. Okay, now in any function, right, if you want to know whether there is a removable type of discontinuity or a non-removable type of discontinuity, then first thing is you should check the limit of the function. If the limit of the function exists, then it will definitely be removable type of discontinuity. And if the limit of the function does not exist, if limit of the function does not exist, then it will definitely be non-removable type of discontinuity. Okay, so what I have told? I have told that there are two main types of discontinuities. One is removable, another is non-removable. Removable type of discontinuities will come when the limit exists, right? Function is discontinuous, but still the limit exists, right? So here, whatever we are talking about the types of discontinuities, and we can talk about the type of discontinuities only when the function is discontinuous. Okay, so we are assuming that the function is discontinuous, and then only we can talk about the types of discontinuities, right? So function is discontinuous, but limit exists. If limit exists, then it will be a removable type of discontinuity, and if the limit of the function does not exist, then it will be non-removable type of discontinuity. Now in removable also there are two main types of discontinuities, which is a missing point type and isolated point. Right, now missing point type, okay, missing point type discontinuities will come if the limit exists, right? Limit should exist for removable type of discontinuity. So in both the cases limit should exist, for isolated also and for missing point also. But missing point type, value of the function will also not be defined, right? Limit exists but value of the function is not defined. In this case limit exists and value of the function is defined, but both of them are not equal, right? Limit is existing, value of the function is defined, but both of them are not equal, right? So basically if I give you an example of missing point discontinuity, it will be something like this. It will be something like this. If I say that this is point 3 and the value at this point is 2, okay, then in this case what is the limit at x tending to 3? The limit of the function at x tending to 3 fx, this will be nothing but 2. So limit exists, right? But the value of the function is not defined. What is f of 3? F of 3 is not defined because there is a circle, right? F of 3 is not defined. So in this type of discontinuities will be called missing point type. And why the name missing point? Because this point is missing. Okay, because if there was a point, if there was a dot here, if I define f of 3 as 2, if I define the function in such a manner that f of 3 becomes equal to 2, then this graph will become a continuous graph. So we can remove this type of discontinuities by defining the function something else, by making a slight change in the definition of the function, right? Instead, if I remove this and if I make f of 3 equal to 2, then it will become a continuous function. Okay, so missing point type. Why missing point type? Because the point is missing. And in isolated point type, it is same as missing point, but in this case the point is isolated. It is not missing, but it is isolated. It is defined somewhere else. So suppose like this. Okay, in missing point type it was completely missing, but here it is defined somewhere else. This is 4 and this is 2. Okay, and this point is suppose x equal to 3. So what will be the limit? Limit of the function will be nothing but 2. And what will be the value of the function? The value of the function at x equal to 3 will be 4, because here there is a dot. Okay, so limit also exists, function is also defined, but both of them are not equal, right? So this point is basically isolated. Okay, it is separated from this part and it is brought here. Okay, so this type of discontinuities are called isolated point type discontinuities. Right, now let us come to this part where we have, again in non-removable, we have three types of discontinuities. One is finite, one is infinite, and one is oscillatory. Right, now for all these three, limit will not exist. Right, now what can be the reasons for limit to not exist? Right, limit will not exist if this condition is not satisfied, which is LHL is equal to RHL is equal to finite. If LHL is equal to RHL is equal to finite, then limit will exist. If this condition is violated, if this condition is not satisfied, then limit will not exist. Right, so first, in finite type discontinuities, LHL and RHL both are finite, but both of them are not equal. LHL is also finite, RHL is also finite, but both of them are not equal. Okay, then it will be a finite type discontinuity. Okay, we will see the example of all this, right? But if I want that, first of all I will tell you about all the types of discontinuities, and then you should figure out what is the type of discontinuities by solving the question, right? So first of all I will tell you full chart, okay, then we will solve so many examples to understand all this. So, and what is infinite type discontinuity? Infinite type discontinuity means either LHL or RHL, any one of them is going up to infinity, or one of them or both, right? So at least one of them is going up to infinity, right? At least one of them should be infinite, then it is called infinite type discontinuity. Okay, and the last one is oscillatory, where the limit is oscillating, right? Suppose the example can be sine of infinity. Now sine of infinity can be any value, right, between -1 and 1, whatever the value, because the range of sine x is between -1 and 1, right? So this value can be anything between -1 and 1, but it has no fixed value, right? It can be -1, it can be 0, it can be 1, it can be 1 point, it can be 0.5, it can be -0.5, right? But the value is not fixed, it is oscillating between -1 and 1. Okay, so such types of limits are called oscillatory types limit, and the type of discontinuity is called oscillatory type discontinuity, right? So first of all, to check, see, if any function is given, if you want to check what is the type of discontinuity, right, first of all be sure that the function is discontinuous, then only we can talk about the type of discontinuity, right? So function is discontinuous for sure, right? Now we are checking the type of discontinuity. So first of all, what you will check? You will check the limit of the function. If the limit of the function exists, then it will be definitely removable type discontinuity. If limit of the function does not exist, then it will be definitely non-removable type discontinuity. In removable also, okay, once you check that the limit of the function exists, then find out the value of the function. If the value of the function is defined, if f of a is defined, okay, if f of a is defined, then it will be isolated point type, and if f of a is not defined, then it will be missing point type. Okay, if limit exists, right, and the function is defined, then it will be isolated. If limit exists and the function is not defined, then it will be missing point type. If limit does not exist but LHL and RHL both are finite but both of them are not equal, then it will be finite type. If LHL or RHL or both goes up to infinity, then it will be infinite type. And if the limit is oscillating, then it will be oscillatory type discontinuity. Okay, this much is clear. Now we will see the examples one by one and try to tell me whether what is the type of discontinuity in the following functions, right? So first example is, tell me the type of discontinuity in this function, which is fx equal to x minus 1 into 9 minus x square into divided by x minus 1, right? Now in this case, first of all you tell me what will be the limit at x tending to 1. Limit at x tending to 1. The critical point is x equal to 1, right? This function is clearly discontinuous at x equal to 1. This function is discontinuous at x equal to 1 because denominator will go 0, critical point. Okay, so we will check about the limit at x equal to 1. What will be the limit at x equal to 1? X minus 1, 9 minus x square divided by x minus 1. Right, now if I want to find out the limit at x tending to 1, if x is tending to 1, that means x is never equal to 1, right? I told you this. If x is tending to 1, that means x is never equal to 1. Either it will be 1 plus or it will be 1 minus. So if x is never equal to 1, I can just cancel out this. Right, so what will be the limit? Limit will be 9 minus 1 square, which is nothing but 8. So limit of this function is exists. Limit of the function exists. So this means that what will be the type of discontinuity? If limit exists, type of discontinuity will be removable. Now in removable, again we have to check whether it is missing point type or it is isolated point type. Okay, so for that we will find out the value of the function. What is f of 1? If I write down f of 1, I will get 1 minus 1 divided by 9 minus 1 square divided by 1 minus 1. In this case the denominator will go 0, right? And if denominator goes 0, then the value of the function will not be defined. If the value of the function is not defined, that means what? This function will be, so limit exists but the value of the function is not defined. That means this type of discontinuity is missing point type. Missing point type. Why? Because limit is defined but the value of the function is not defined. Okay, missing point type. Let us see the second example. Next example is this, right? X power 4 minus 4 divided by x minus 2. Now again find out the limit of this function At this function is discontinuous at which point? This function is discontinuous at x equal to 2 because it is the critical point, right? So at x equal to 2 I will find out the limit. At x equal to 2, what will be the limit? You can just factorize, right? So this will be x square minus 2 divided by x square minus 2 divided by x square plus 2, right? Because a square minus b square whole square and divided by x minus 2. Okay. Alright, I think here there should be 16. Make it 16 because otherwise you will not be able to factorize, right? If this is 16, then basically here you will get 4, right? X square minus 4 and x square plus 4. It should be 16, right? So again if you will factorize, x minus 2 will get cancelled. X plus 2 into x square plus 4. This divided by x minus 2. And what is limit? Limit is x tending to 2. If x is tending to 2, that means x is never equal to 2. So this thing will get cancelled. And what will be the limit? Limit will be 2 plus 2 into 2 square plus 4. Okay, so this is nothing but 4 into 4 plus 4, 8. Right, so this will be 32, which is, so limit exists, which is finite, right? So limit of this function will exist, right? And now if the limit exists, what can I say? If limit exists, then it will be a removable type discontinuity. This will be a removable type discontinuity. Now in removable type, which whether it is missing point or isolated point, for that we will have to check the value of the function. So what is the value of the function? F of 2. F of 2 will be not defined, right? Because denominator will go 0. If I write down f of 2, that means this will become 2 minus 2. So denominator will go 0, right? So value of the function is not defined, right? So limit exists, but value of the function is not defined. That means point is missing, right? So this is missing point again. So this is also missing point type discontinuity. Okay. Now let us go to the third question. Third question is, tell me the type of discontinuity. Again in this question, which is fx equal to greatest integer of x plus greatest integer of minus x. Okay, so greatest integer of x plus greatest integer of minus x will be, this will be 0 if x is integer, and it will be minus 1 if x is not integer, right? You can apply the definition of greatest integer of x plus greatest integer of minus x, you will get this, right? So if I try to plot graph of this, right, for this it would be easy if you try to plot the graph, right? Wherever x is integer, x integers means 0, 1, 2, 3, 4. At all the integral points, the value of the function is 0. So all these dots, value of the function is 0. And at all the non-integral points where x is not integer, there the value of the function is minus 1. Not here. It will be minus 1. Minus 1 will be here. So circle, again circle, okay, again circle. So it will be like this. At all the integral points, the value of the function is 0, and at all the non-integral points the value of the function is, so at all these points, non-integral points in between 0 and 1, there the value of the function will be minus 1. Okay. Now from the graph, can you tell me which is the points of discontinuity, where the function is discontinuous? The function will be discontinuous at all the integral points. At all the integral points, right? 0, 1, 2, 3, 4, at all the integral points the function is discontinuous. And what is the type of discontinuity? The type of discontinuity will be, see, the point is missing from here and the point is present here. So that means this point is isolated, right? If this point was present here, then the function would have been continuous, but it is shifted a bit, right? So this is nothing but isolated point type. The point is isolated. So in this case also, if you find out the limit will exist, right? So what is, if I talk at x equal to 1, at x equal to 1, what is the limit? Limit of this fx at x equal to 1. At x equal to 1 means I will check for at x approaching 1, right? So I will check for x equal to 1 plus and x equal to 1 minus. So at 1 plus the value is minus 1, and at 1 minus also the value is minus 1. So limit exists. So it will be removable type discontinuity, right? And in removable, what is the value of the function? What is f of 1? 1 is an integral point, so f of 1 will be 0. So function is also defined, limit also exists, but both of them are not equal. So this is isolated point type discontinuity. Okay, so from the graph also you can see it, and from the definition of the function also, from the definition of continuity also you can see it, right? Example 4 is, tell me the type of discontinuity if fx is equal to mod of sin x by x, right? Now mod of sin x by x will be, so this will be discontinuous at which point? At x equal to 0 we have to check, right? Because the critical point is x equal to 0. So let me find out the limit at x tending towards 0. So at x tending to 0, what will be the limit? The limit of this function will be, so first of all let me find out RHL, right? RHL will be for x equal to 0 plus, okay? So at x equal to 0 plus, I will get sin of x divided by x. Now if I am talking about at x equal to 0 plus, what is the graph of sine? Sin x will be something like this, right? Graph of sin x will be y equal to sin x. Now at x equal to 0 plus, you can see that sin x will be positive. This is 0 plus, and at 0 minus sin x will be negative, right? So basically here the mod will open in plus sign, right? Because sin x is positive, so mod will open with a plus sign. So sin x by x, and what will be the limit x tending to 0? Here there is limit x tending to 0. So limit x tending to 0, this will be 1, sin x by x, right? And similarly, what will be LHL? LHL will be limit x tending to 0 minus mod of sin x by x. So this will be nothing but x tending to 0 minus. Now if I check for 0 minus, then the sin x will be negative, right? If x is less than 0, slightly less than 0, then mod of sin x, this sin x will be negative, so mod of sin x will open with a negative sign. So minus of sin x divided by x, and sin x by x, what is the limit of this? X tending to 0, sin x by x is 1. So limit of this quantity will be minus 1. So from here you can see that RHL is 1, but LHL is minus 1. Okay. So in this case, limit does not exist. LHL is not equal to RHL. So limit does not exist. If limit does not exist, then what can I say? This will be a non-removable type discontinuity. Non-removable. Right? And in non-removable, which is the type of discontinuity? Right? LHL is also finite. RHL is also finite. LHL and RHL both are finite, but both of them are not equal. So this is a finite type discontinuity. Understood? LHL is also finite and RHL is also finite. So this is a finite type discontinuity. Okay? And in finite type discontinuity, there is one more term which is defined, that I will write down here also, which is called jump of discontinuity. Jump of discontinuity. And what is jump of discontinuity? Jump of discontinuity is nothing but mod of RHL minus LHL. Now mod of RHL minus LHL means mod of 1 minus minus 1. Right, this is called jump of, so whatever is the difference between LHL and absolute difference, right? So we will take mod also. So this will be nothing but 2. So jump of discontinuity from, so basically from minus 1 to 1. So jump is 2, right? So there is one more term which is defined exclusively for this only, right? Finite type discontinuity only. So if jump of discontinuity is given in some question, that means it is sure that it is finite type discontinuity only, right? This GOD, jump of discontinuity, this term is defined only and only for finite type discontinuity only, right? If it is infinite type discontinuity, you cannot define jump of discontinuity. Jump of GOD will not be defined. It is defined only for finite type discontinuity. Okay, only if this is the type of discontinuity, then only you can find out jump of discontinuity, otherwise not. Okay. Now example 5. Example 5, it is fx equal to tan inverse 1 by x at x equal to 0. Again we have to check. So again tell me what is LHL. LHL will be f of 0 minus. So f of 0 minus means limit x tending to 0 minus tan inverse. This will be 1 by 0 minus, right? X is 0 minus, right? So this will be how much? This will be nothing but tan inverse. So 1 by 0 minus, 1 minus a slightly less than 0 negative quantity, right? So this will be nothing but minus infinity. So value of tan inverse minus infinity is minus pi by 2. Okay, what will be RHL similarly? RHL will be nothing but f of 0 plus, and f of 0 plus will be limit x tending to 0 plus. So here I will get tan inverse 1 by 0 plus, and 1 by 0 plus means slightly very small positive quantity. Okay, if this is very small positive quantity, 1 by this quantity will be infinity. So this is tan inverse plus infinity, and this will be nothing but pi by 2. So in this case also you can see that LHL is not equal to RHL. Okay, so limit does not exist, right? So limit does not exist, and if limit does not exist, this implies that it will be which type? Non-removable type. And in non-removable type also you can see that non-removable type of discontinuity, and also you can see that LHL and RHL both are finite. Both are finite. This is also finite and this is also finite. Okay, so I can say that this is a finite type discontinuity. This is finite, and in finite type discontinuity, what will be GOD? Jump of discontinuity. This is nothing but mod of RHL minus LHL. So this will be nothing but pi by 2 minus pi by 2. So pi by 2 plus pi by 2. So pi. Okay, so jump of discontinuity will be pi. Now example 6, tell me the type of discontinuity in fx equal to 1 by x square at x equal to 0. So at x equal to 0 this function is discontinuous, and we have to tell the type of discontinuity. Okay, so in this case, first of all you tell me what is the limit. So first you tell me what is LHL. LHL will be limit x tending to 0 minus, right, and 1 by x square, x tending to 0 minus, so 0 minus whole square. So this will be how much? This is a negative quantity, right, but if I am squaring it, it will become a positive quantity, right. So this is a very small positive quantity in fact, right. So this will be infinite, 1 by 0, right, and RHL will be limit x tending to 0 plus 1 by x square. So this will be 1 by 0 plus. 0 plus is very small, or you can just write it as 1 by h square, where h is a very small positive quantity and h is tending towards 0. So this will also be infinite. Okay, in this case also limit does not exist. In this case also limit of the function does not exist. So what will be the type of discontinuity? Type of discontinuity will be non-removable. Non-removable type of discontinuity, right? And in non-removable type of discontinuity, you can see that LHL is infinite, RHL is also infinite. So type of discontinuity will be infinite type discontinuity, and in this type of discontinuities we cannot define a term which is called jump of discontinuity, which is exclusively for finite type only. Here we cannot define any such quantities. Now example 7 says that fx is equal to sine of 1 by x at x equal to 0. Okay, so in this case again let me check for the limit, right. What will be the limit at x tending to 0 of this function sine of 1 by x? Now this is nothing but sine of, basically I will get 1 by 0 plus if I talk about RHL, right. This is RHL. So this will be nothing but sine of infinity, and sine of infinity will be, so this is the graph of sine, right. Graph of sine is like this. So what will be the value of this function at x if x is tending towards infinity? At infinity, what will be the value? It will be some value between minus 1 and 1. I don't know what value, but it will be some value between minus 1 and 1 only, right? Because sine of anything will always be between minus 1 and 1. Okay, so this will be some value between minus 1 and 1 only. Alright. Again, if you check the LHL will also be sine of 1 by 0 minus, which is again sine of minus infinity, and sine of minus infinity will also be oscillating, which is between minus 7 and 1 somewhere, right. So such type of limits are called oscillatory limits, where the limit is oscillating, right. So this type of discontinuity will be oscillatory type discontinuity. So we have solved many examples. I hope this type of discontinuity section is clear to you. Reasons and types of discontinuity both are clear to you. So students, in this part we have seen what are the different types of discontinuities, and also I will tell you about what are the different reasons for discontinuity. Now even in our next part I am going to tell you about the theorems that are related to continuity. So stay tuned till then. Thank you.